Picture this. The year is 1 billion years in the future. The continents as we know them have vanished, merged into a vast unfamiliar land. The air is thick and scorching. The oceans shrunken to shallow remnants, or gone entirely. Welcome to Earth, 1 billion AD. In this journey through time, we'll explore how our planet might realistically appear a billion years from now based on what science tells us today. It's a vision at once fascinating and sobering, a world almost unrecognizable, yet forged by the same natural forces that shape our Earth now. 1 billion years is an almost incomprehensible span. For context, a billion years ago from today, the first complex cells were just evolving and an ancient supercontinent called Rodinia was breaking apart. Fast forward that same amount of time into the future, and the changes will be even more dramatic. Earth's plate tectonics, climate, and life will have had a geological eternity to transform our world. So what might we find on this far future Earth? Let's start with the most obvious change, the ground beneath our feet, the continents themselves. Over hundreds of millions of years, Earth's continents move like slow-motion puzzle pieces. A billion years from now, that motion will completely redraw the world map. It's highly likely that all the continents will drift back together, colliding to form a new supercontinent. Geologists have even given future supercontinents names like Pangaea Ultima or Amasia. Whatever it's called, imagine a single colossal landmass dominating the planet, surrounded by a vast global ocean on the other side. Mountains will rise where continents crash together, forging towering ranges that make the Himalayas of today look young and small. Meanwhile, coastlines will shift and stretch in massive new configurations, and ancient seabeds will be lifted into high plateaus. In the center of this supercontinent, conditions will be extreme. Rain clouds from the ocean will dump most of their moisture near the coasts, meaning the continental interior could be an immense, parched desert. Think of a place far hotter and drier than the Sahara. In fact, one recent climate study of Pangaea Ultima, a supercontinent expected much sooner, as 250 million years from now, found that its inland areas could reach temperatures higher than any modern desert and be up to 4 times as arid overall. The Earth's land in 1 billion years could look stark and alien, with a single continent covered in scorched mountains, salt flats where inland seas used to be, and gigantic desert plains where life once flourished. By the way, if you're enjoying this speculative journey into Earth's distant future, consider subscribing to our channel. We explore science and imagination just like this, and your support lets us continue voyaging across space and time. Thank you. Now, back to our 1 billion year odyssey. Let's see how a brighter sun transforms our planet into a truly extreme world. 1 billion years from now, the sun will be shining about 10% brighter than today. 10% might not sound like much, but when it comes to the sun's power, that is enormous, more than enough to turn Earth into a pressure cooker. All that extra sunlight pouring down will pump energy into Earth's climate system, with catastrophic results. Scientists predict that around this time, Earth will be pushed into a moist greenhouse state. In a moist greenhouse, warmth from the brighter sun causes the oceans to evaporate at an extreme rate. Picture the seas turning into steam. Vast quantities of water vapor surge into the atmosphere, trapping even more heat, since water vapor itself is a potent greenhouse gas. It's a vicious cycle. As the planet gets hotter, more ocean water boils into the sky, which in turn increases the greenhouse effect and heats the world even further. The result? Unending summer everywhere. Global average temperatures will soar far beyond anything we humans have ever experienced. With the atmosphere choked with water vapor, humidity could be near 100% in many regions, making the heat even more oppressive. Like a giant, wet sauna encompassing the whole planet. Eventually, this steam trap will likely spell the end of Earth's oceans as we know them. By this time, most of the oceans will have vanished into the air, leaving behind enormous dry basins streaked with mineral deposits. We might see only small, hypersaline seas or lakes clinging on near the poles or in the deepest depressions, where it's marginally cooler. But much of the world that was once covered by deep blue water will become barren, cracked salt flats and desert. Standing on what used to be an ocean floor, you'd see the horizon waver with heat haze. Any remaining water on the surface might exist as boiling mud pools or inland seas so hot and salty that few life forms could survive in them. All this upheaval will also change the very air around Earth. Right now, we live in an atmosphere rich in oxygen, thanks to photosynthetic life. But in the future, as the climate turns hostile, plant life will decline drastically. With hotter temperatures and less water, many plants will die off, and eventually they won't be able to replenish the oxygen in the air. Researchers estimate that Earth's oxygen-rich atmosphere may only have about 1 billion years left before oxygen levels plummet. 1 billion years from now, the breathable air we take for granted could be largely gone. The atmosphere might revert to something like it was in the distant past, long before complex animals evolved, dominated by nitrogen with a lot of carbon dioxide and water vapor, but very little oxygen. In essence, the air would be unfit for humans or most animals. If you were miraculously able to time travel to this era, stepping outside without a high-tech spacesuit would mean instant suffocation. The air simply wouldn't have enough O2 to breathe. The loss of oxygen also means the loss of the ozone layer high above Earth, since ozone is made from oxygen. Without that shielding, intense ultraviolet radiation from the beefed-up sun will scorch the surface unfiltered. The sky itself might appear different. On the rare occasion it's clear of clouds, the daytime sky could still show a familiar blue hue. Nitrogen will still scatter blue light, but it might be a paler, hazier blue due to the heavy humidity or dust. More often, the sky could be veiled by a white-hot haze or yellowish clouds. The sun would beat down with a blinding intensity, likely appearing slightly larger in the sky than today, as the sun will expand a bit as it brightens. And there's another subtle change that future sky gazers would notice: the moon. Our moon is slowly drifting away from Earth a few centimeters each year. In 1 billion years, it will be tens of thousands of kilometers farther out than it is now. That means it will look smaller from Earth. In fact, by around 600 million years from now, the moon will no longer appear big enough to completely cover the sun. Total solar eclipses will be a thing of the past, so in 1 billion years, an eclipse would only be a partial one, with the moon gliding in front of the sun like a dark disk that never fully blots it out. On top of that, Earth's rotation will have continued to slow down, thanks to the moon's gravitational tugs. A day in the far future might be significantly longer than 24 hours. Calculations suggest that in about 180 million years, the day lengthens by roughly an hour, so in 1 billion years the planet could be rotating so slowly that daylight lasts for 30 hours or more. Imagine the sun baking the land for that much longer each day, and long stifling nights that barely cool down. It's a world where even the fundamental cycles of day and night have changed. With hellish heat, no open water, and a suffocating atmosphere, life on Earth will struggle to survive, to put it mildly. The vast majority of plants and animals will be gone by well before the billion-year mark. In fact, long before the climate reaches the extreme we've described, many forms of life would have already perished. For example, land mammals, like humans, are unlikely to survive even the next 250 million years if Earth's continents merge and the climate becomes as hot as predicted. By 1 billion years from now, it's almost certain that complex multicellular life, the kind of rich ecosystems of trees, insects, fish, birds, mammals, etc. that we know, will have been wiped out. Scientists note that once oxygen levels collapse and temperatures spike, Earth will no longer be able to support those complex oxygen-breathing life forms. The extinction event would be gradual but inexorable. First the big animals go, then the smaller animals and most plants, until only microbes remain. So in that distant future, who are the last survivors? Perhaps only hardy microorganisms, bacteria or archaea that can endure extreme heat and find refuge in niche environments. Maybe some could survive around deep underground water reservoirs or geothermal springs or high in the cooler layers of the atmosphere. Life has a way of hanging on in seemingly impossible conditions. We have microbes today that live in boiling hot springs and deep rock. It's conceivable that a few resilient species could persist even as Earth becomes more like an oven. But any life would be minimal. The rich tapestry of blue seas teeming with fish and green forests alive with animals will be gone. In its place, a billion-year-old Earth might have a few faint traces of biology, microbial mats clinging to an evaporating pond, or colonies of heat-loving bacteria living beneath the soil. On an otherwise barren planet, for all intents and purposes, Earth will have reverted to a lifeless or nearly lifeless world, not unlike it was billions of years in the past before life emerged. So, how will Earth look in 1 billion years? In summary, it will be a world transformed. Where there were once separate continents, there will be one supercontinent, a massive dry expanse scorched by a far stronger sun. The oceans will have largely evaporated, leaving dry land and baked salt pans where blue waters used to roam. The atmosphere will be dense and toxic by our standards, likely rich in water vapor and carbon dioxide, but nearly devoid of the oxygen that once powered complex life. Life on the surface, if any remains, will be nothing like the vibrant biosphere of today. It may survive only in microscopic forms in isolated refuges. To an observer, Earth would appear as a hot, cloud-covered planet, perhaps with a glaring sun peeking through a dull haze and a giant barren supercontinent below. It would be a far cry from the blue-green marble we call home in the present day.